Good morning, class. So we are on Unit 6 sinusoidals. There are 6 lessons associated with this. So it says that you need to be ready for this unit by knowing all of these. So go through this as a checklist. So I need to transition you into Unit 6 from Unit 5. So on the next 2 pages, I kind of go over how are we going to go from trig ratio to the sinusoidal function. So I start off by drawing the unit circle, which you're familiar with from the previous unit. And you are using the x and y values to graph your unit circle, right? And you are basically able to get the associated degree that you get with the coordinates, with the respective coordinates. Instead of graphing y versus x, which is the dependent versus independent, what you're doing is you are graphing y equals sine theta instead, where the y that I'm talking about isn't the same y that I'm referring to from the unit circle. So for example, at 0 degrees, I need to know what my y value is, because in this case, my y value is equal to sine theta. So when I plug in 0 degrees into this, what do I get? Well, you can use a calculator, but I like using the unit circle so we avoid using the calculator and know where this is coming from. So for example, when I look at 0 degrees, my y value is equal to 0, right? And I do need to write this part where it says, well, my sine theta from the previous unit came from the fact that it was y over radius. And that was based on the triangle we were able to draw on a unit circle, and where let's say like this is the y and this is the x and this is the r, and because that's like the opposite and that's the hypotenuse, that's where sine theta equals y over r came from. All right, quick recap. So y value is a 0 at 0 degrees, and the radius is always going to be a 1 for a unit circle. So at 0 degrees, my sine theta is equal to 0. That is my first coordinate I have for this graph. For the 90 degrees, I have a y value of 1. So I'm not going to put like 1 over 1 every time. So I'm just going to put a 1 there. And then at 180 degrees, my y value is 0. At 270 degrees, my y value is -1. At 360 degrees, my y value is 0. So I hope you can see that we're basically using the unit circle, and we are using it as a way to graph y equals sine theta, which is like a totally different looking graph. So when we use the Desmos to graph it for us, so you can see that it's going to say 0, 0, 90, comma 1, 180, comma 1, 270, comma 1, and 360, comma 0. So your Desmos isn't going to have x like associated with in degree mode, and so it's just gonna spit it out as numbers. But we said that during the last unit that pi is equal to 180, and I'm just gonna like simply plug that pi for 180, and that's how I got 90 degrees. Remember in grade 11 we are mostly looking at trig or sinusoidal functions in terms of degree and not in radian mode, and that's why I keep using the degree mode just to be consistent, all right? So that is what a sine theta function looks like. You start off at the origin, you go up, you're gonna come back to the origin, and then you're gonna come back to make these like 2 little mini waves, and that represents 1 cycle. And I'm noticing that in 1 period, there are, it makes 1 period in 100, within 180 degrees. That's wrong. That should be 360, right? Because 2 pi is equal to 360. That makes more sense. A full circle is 360 degrees. So a full cycle for a sine theta, if it hasn't really transformed, it should have a period of 2 pi, like because it's kind of made a full circle around the circle. So that was y equals sine theta. With the same idea, you are going to figure out your table of values for cos theta. So for 0 degrees, well, remember that if you look at this like mini messy triangle I made, my cos theta is equal to, well, according to SOHCAHTOA says CAH, and so this is adjacent. Therefore, it's x over r. And so I'm just going to write that my cos theta is equal to x over r, and my x value at 0 degrees is 1, and my radius is always 1 for a unit circle. So we're actually going to start off at 0 degrees, comma 1 as the first coordinate for cos theta. For 90 degrees, it's x divided by r. I'm not going to keep writing the x divided by r actually. And so x is 0, I notice. And the r is automatically a 1. And so that is going to be 0, right? And then for 180 degrees, my x value is a -1. So I'm just going to follow all the x values all the way around. At 270, it's a 0. And then for the 360, it's a 1. So notice that this is a table of values for y equals sine theta versus y equals cos theta. And so we're mostly going to be looking at these kind of looking functions, and this is the sinusoidal functions. So basically what a sinusoidal function is that it's going to have some kind of pattern to it that if it was to extend like waves in the ocean, the waves are going to come back and it's consistent and it's going to have like the same period for every cycle, okay? So this is what y equals sine theta looks like, and this is what y equals cos theta looks like. Interestingly enough, notice that if I like shifted this, let's say blue graph over, then it's going to look exactly the same as the red graph, which is the y equals sine theta. So all y equals sine theta and y equals cos theta, all that there is that they're like shifted versions of one another. It's like there's a horizontal shift between the two, and we are kind of like working with the sine theta versus cos theta, which have different characteristics, but very similar in ways because as I kind of told you, you can really kind of represent them from one another by describing the shift, but we're not there yet. So I just want you to understand how we can go from that unit circle to a table of values to graph it. So I was throwing you a bunch of words, and these are kind of the words that you're going to see in Unit 6, Lesson 1. Some words kind of might sense just because like of logic, maybe, I don't know. So one period, like in one cycle, like it's a 2 pi for one cycle, one period. How long does it take for the graph to return to its original position? So we notice that this occurs for 360 degrees. So that is what a period is. Range, we already know what that means, right? That where does a y exist? So unfamiliar words are probably these. Axis. So axis is, it's not really the x-axis and the y-axis, although it might just look like the x-axis to you. It's the y value where the curve oscillates around, like goes up and down around. So for example, if my waves were up there and it was going like this, my axis would actually be y equals 2, okay? So notice that it's kind of like oscillating and coming back always towards y equals 0, and that is the axis. Amplitude. Amplitude is what is the number, what is the positive number that is between like the axis and the max, or let's say the axis to the minimum. So like from the middle of that curve, the function to the top of the curve, like how much should I shift by? Well, it's basically my curve is going up by 1 down to the axis, down by 1 and up to the axis. The amplitude is 1. So hopefully this overview will help you prepare for Unit 6, Lesson 1. All the formulas and key characteristics are going to be within the lesson itself.
So I just want to put a disclaimer. The way I word my phrases in my next clip to this video is that I assume that you have seen this numerous times. So you should be looking at the table of values and plotting because you need to follow some kind of instruction to be able to plot things, right? This is like following the recipe. But once you graph this a couple times, you might notice patterns and how to graph it quickly. And based on that, I wrote the freehand the way I remember how to draw it. So this part of the clip kind of helps you to see my thinking process on how to draw this. So please keep that in mind. Don't assume you'll be able to draw this on your first try. Maybe after a couple, 5, 10 tries, it's gonna all kind of come together, okay?
So we're not going to have Desmos, and we are going to be freehanding these graphs, and we can do a even better job than Desmos, and we can just use Desmos as a way to double check. So there are a couple of characteristics that I remind myself of when I'm freehand drawing my y equals sine theta and y equals cos theta. So first thing is, oops. So sine theta and cos theta both have a period of 360 degrees. So 2 pi, ahem, like full unit circle. So a full unit circle consists of 360 degrees. So that's basically where it's coming from. For sine theta, so sine theta and cos theta, I have to remember kind of quickly how to draw it. And this is the way I remember. So sine theta is the one that starts at the origin. Okay, and then it ends at 360 degrees, comma 0. And then I remember that there's like two little mini waves to it. So trust me, I've done this like 100 times, but once you've done it often enough, you'll get it by the fly. Okay, so you start off at the origin, right? And then I go in, I know that with my sine theta, it had like a max value of 1 and a min value of -1. So that's what I usually draw. Um, so 1 and -1. So I know how to draw from there. Okay, and then I usually go, well, I have to end at 360 degrees. That's like my end of the cycle for that first cycle. And then, well, and I go in my head or using a calculator, okay, well, point between 360 and 0 is 180 degrees. And I know just by doing it a lot, there's like 5 coordinates associated with this. And that means I kind of want to have five point of references. So from here, well, a number between 0 and 180 is 90. And then the number between 180 and 360, because we saw the unit circle so many times, is 270. But what you can do is 180 plus 360 divided by 2. That's what you can do every time. All right, and so I know that the what sinusoidal function is that it will start and end at the same point, right? At the same y value. And so I'm going to put a dot there. And then I remember that with the sine theta, there are two mini waves. And I put a dot in the middle to introduce these two mini waves. And so it's going to hit a max of 1, and then I'll draw the little mini wave, the first wave, and then it's going to hit the minimum, the -1. And that's my awesome y equals sine theta. And then I'm going to draw my y equals cos theta. So y equals cos theta, well, it's really the same idea. Like I know that like it'll have very similar characteristics. I'll draw the 1, the -1, everything. I'm going to keep consistent. I'll just put little dashes there. So what I remember is that for cos theta, instead of having many waves, cos theta starts at 0 degrees, comma 1. That is the first coordinate, and then it ends at 360, comma 1. It starts and ends at the same y value. So I'm going to start at the maximum, and then I'm going to end at the maximum. And it's going to have one big wave to its single cycle. And if I'm going to have a wave, that means that it has to hit the minimum at some point, and it's going to make sense to have it right in the middle. And I'm going to draw the dots here to help me draw. And so you're not going to draw like this, please. That's not going to work out. That's like what an absolute value function looks like. Remember, this function, when you plot it, look more like waves. So it doesn't have to be perfect, but kind of connect the dots and you have it right there. So this is how you can freehand draw this y equals sine theta, y equals cos theta. And even when I have like complex transform sinusoidal function, I kind of stick with, drawing my max, drawing my min, drawing my last point of the period, drawing the reference points as I need, and every sinusoidal function, a sine theta is gonna look like this, although there might be transformations involved, it's gonna always look like this. I just have to scale it correctly. And then y equals cos theta, it's going to look like this big wave, and for y equals positive cos theta, it's going to look like this. And you can try to reflect what y equals negative cos theta looks like, or y equals negative sine theta looks like if you're ready to get there. But basically, spoiler alert, it's going to be a reflection along the x-axis, so it would look like this if there was a negative in front. All right, but this is the function that you want to be able to draw eventually confidently, and I know you'll get there.